learning goals are in lesson 3.5. I can create and interpret a scatter plot, and I can use trend lines to make predictions. In other words, the title of our lesson, scatter plots and trend lines. Okay, let's start with our first vocab word. What is a graph with points that are plotted to show a relationship between two data sets? Carly?
Scatter plot.
That's called a scatter plot. When you have a graph and it has points plotted showing the relationship between two sets of data, we have a scatter plot. One of the sets of data is represented by the x value. The other set of data is represented by the y value. In fact, I would like you to add this to it. What kind of a graph is a scatter plot? Is it continuous or is it discrete? Isaiah?
Discrete.
It's discrete. We do not connect the dots on a scatter plot. We do not connect the dots. We show the relationship and we show it as a discrete graph. Okay? So let's practice first of all graphing a scatter plot, which you should have already done in your SQ3R. But here's the really important part that students leave out when they're graphing scatter plots. You don't make it reader friendly. In other words, somebody looks at it, they see a bunch of points on a graph, they see some numbers, and that's all they see. They have no idea what that scatter plot is representing. So here's one where we have the two sets of data that are going to be compared are the game. What game number was it? Was it the first game, second game, third game, or fourth game? And how many points were scored? Now, these are points scored by what? What type of a sport?
We don't know.
Yeah, we do.
Oh.
Football team. So you know what? We're going to take that and we're going to write that at the top of that's going to be the title of our graph. We're going to say, this is a football team. So when I look at that, I say, well, they're going to tell us something about a football team. And then I have to decide which one's going to be represented on which axis. And it doesn't really matter in a scatter plot. We don't necessarily talk about independent and dependent in scatter plots. So, Ricky?
The one going up being game?
The one going up being game? Okay, I'm going to look at that. I'm going to look at the coordinate plane that I've set up there for you, and I'm going to say, you know what? For games, I only need the values 1, 2, 3, and 4. But for the scores, I need from the lowest score is 6, and the highest score is 46. So do we think we want to put the scores on the x-axis?
No.
I think it might be a better choice to put the game on the x-axis. So we're going to label the x-axis as game, and the y-axis is going to represent the score of that game. So again, when the reader looks at it, they should be able to tell what are the x values of your points, what are they representing, and what are the y values of your points representing. So we're not graphing yet, we're just getting our graph labeled. We're just getting it so it's going to be a nice graph. Well, games, we just have to go from 1 through 4, so we can use a scale of 1 on the x-axis. We can let each grid line represent one game. And then on the y-axis, we have our lowest score is 6, our highest is 46. Do you think we're going to be able to use a scale of 1 on the y-axis?
No.
No. So Cole's holding up 5 fingers over. If he's thinking 5 would be a good one. How do you feel about 5? Yeah. Now here's what we don't do, and this is typical. This is what students sometimes do, and we don't do this with a scatter plot. So don't copy what I'm going to do, but I'm going to show you what I see students do. Okay?
That'd be something.
Looks like a shortcut, doesn't it? It looks like a nice, clean-cut way to do this, doesn't it? You know, like, do you think that's good? Is that a good? In other words, remember the axis is a representation of the number line. So is that a good representation of the number line on the y-axis?
No.
One distance is 6. The next distance is how much?
21.
No, the next distance between 6 and 21 is?
1.
No.
Away.
It's one grid line, but what's the distance that it's trying to represent?
15.
15. So the same amount of distance from here to here, that was 6, and now for the same amount of distance, that's 15 units. That's 15 points. And now from 21 to 34, that's how many?
13.
13, and then from 34 to 46 is 12. Now, is that a good number, Mike?
No.
No, so we can't just be like, well, whatever makes it easiest for me, that's what I'm gonna do. We have to decide what would be a good scale, and I kinda like whole scale of 5, and some of you agreed, so let's go by 5s on the y-axis. And if you decide not to label every grid line, then you've gotta go according to, you wanna make sure that then you're allowing for that one that you skipped over and didn't give its actual label. I did label everyone, but it gets pretty busy. So the very last grid line that I didn't label at the top would be 55 points. Okay? So, now go ahead and graph those 4 ordered pairs that you have. But be careful, because on a scatter plot, they don't fall nicely all the time. The points don't fall nicely on an intersection of grid lines. Make sure that you do it so that it's as accurately done as you can get it. So every time, except for the one time, 621 and 46, they were all 1 point above the grid line, so we'd only go a fifth of the way up. And then when it's 34, that should be right below the 35 because it's 1 point below 35. So we have to put them in good locations, okay? Okay, so Ricky.
What if I just put like estimated around where they would be on there if we're going by 5s for each of the black lines instead of putting all of those down?
That's what we all did.
Oh, because you put like 50s on there.
Oh, you should be numbering. That's called labeling. You need to label your graphs. A lot of you on the quiz didn't. Amazingly, there was this graph that I started for you. I was so nice. I didn't even make you draw the coordinate plane. I labeled the axes for you, what would get represented on each one. My picture scale for you, I started to label, and some of you were like just too lazy to finish labeling. And so we have to take time to do that first. Make a good graph, a good setup, and then do the actual graph. So everything else on here except the points, none of that is graphing. That's just labeling our graph, getting it ready. Okay? Do we connect the dots? No. It's a discrete graph. Scatter plots are discrete. Okay, what's our next vocabulary word there? Describes a relationship between 2 data sets. Michaela. Correlation. We should have learned in our study of this lesson that when we talk about the relationship that 2 data sets have, we call it correlation. Okay, Riley?
Oh, I was gonna answer.
You want to start talking about the next ones? You want to start filling in the next blank or ask a question? You want to start filling in the next blanks? Okay. So there are 3 types of correlation. When both sets of data increase, or in other words, as you move across the x-axis, the y values also go up. What kind of correlation is that called? Go ahead, Riley, I'll let you have that one.
Positive
That one's positive correlation. So as one increases, so does the other. And when you have to describe correlation in your homework, that's what you're going to do. You're going to say, you know what, here's what's happening. Let's describe the correlation that's happening in that graph up here. What's happening? What kind of correlation is going on there? Isaiah?
Excuse me, positive.
Okay, it's positive correlation, and how would we describe that? Go ahead, Isaiah.
Well, both sets of data, both all points increase.
So the points are rising, aren't they, from left to right? So as you go across the graph, as you move from left to right, there's rising. But what's really happening? As the game numbers increase, the scores increase also. And it doesn't have to keep the same pattern. Notice the 4th game didn't increase, it went down a little bit, but in general is the pattern an increasing pattern. The more games they play, the better score they're getting. Okay? So as the games increase, so do the scores tend to increase. That's what we would say when we're describing, and we would say, so yes, that shows positive correlation. Okay, what happens then if as you're going across this way, as the x value, that data set is increasing, But the other ones, they were starting up here and they start coming down as you go across the graph. What kind of correlation is that, Carly?
Negative.
That's negative correlation. As one increases, the other decreases. And notice it doesn't say they both decrease. Only one of them is decreasing while the other is increasing. Isaiah?
So, for negative correlation, does it matter whether the X or Y is increasing?
Typically, no, it doesn't matter which one is. It just depends on how you're reading the graph. So typically, don't we read from left to right? So typically, we always look at, as X increases, what's happening to Y. So usually the Y's, we're kind of looking at what happens to the Y. So if as X is increasing, the Y's are increasing, then we say, okay, positive correlation. If as the X's are increasing, the Y's are decreasing, they're coming down, then we say negative correlation. What's our third type? Ian?
No correlation.
No correlation. No correlation between there's no relationship basically between them. What would the graph look like when there's no correlation? What does it look like then, Riley?
Just a straight line.
Just a straight line? I think that just shows a pretty strong correlation actually. Ricky, what do you think?
It's just a bunch of plot or little dots everywhere on the graph.
The points are kind of all over the place, aren't they?
So it's a mess.
You can't really tell a pattern, in other words. It's not really, if you really want to call it a mess, it's really not even a mess, it's just there's no pattern. There's nothing really happening, no sort of a relationship developing between them. Okay, so let's look at our graph here that notice something about it, because this is what you guys will tend not to do. I'm going to point out some things. The graph has a title. The x-axis has a label. The y-axis has a label. Oh, and look at what else. All the way across the x-axis, there's some labeling that shows you how to read it. All the way up the y-axis, there's some labeling to show you how to read it. Before they even graphed it, they did all that. Ricky?
Could there be all real numbers scatter plot, like everything just filled in?
That'd be a black.
Or could it be white if you're using white
There could be, but it would, I'm not really sure what we could compare as one data set to another that would any combination of numbers would work. I'm not really sure I can come up with one right now.
Car sold, the car sold.
I don't think so, Ricky, I don't think that's gonna do it. Okay, so let's now that we're back to showing you how a good graph, a good scatter plot looks before you actually put the points on it, let's talk about the correlation in this one. As the daily average temperature, let's go across the graph, increases, as the daily average temperature increases, so as we move across the graph from left to right, what's happening to the number of visitors on the y-axis? Are they going up, down, or are they all over the place?
Up.
They have a general pattern of going up. So we would say the number of visitors increases also. So what kind of correlation do we have then? Positive correlation. Okay. So it's positive correlation, and that's what helps support it. As the daily average temperature increases, so do the visitors at the beach. Which sounds typical, right? The warmer it is, the more you want to go to the beach. And of course, we don't have too many beaches in North Dakota, but okay. Now let's do it without a graph. Identify the correlation you would expect to see between the pair of data sets and explain. So the average temperature in a city and the number of speeding tickets given in the city. Okay, what do you think? No correlation. Why not? What's our explanation going to be?
There's no relationship between temperature and speeding tickets.
Okay, so you're saying the temperature outside really should not affect how many speeding tickets are given out. Carly?
Disagree.
You're going to disagree. Okay, what do you think it should be then?
Well, when it's icy, people would speed less.
Okay, so you're saying that as the temperature goes down, so would the number of speeding tickets go down, or vice versa. As the temperature goes up,
Yeah,
so would
right.
the number of speeding tickets.
I mean, kind of. Yeah.
Okay, now, does this say in North Dakota,
But it could be anywhere,
Specific.
like Canada.
That's the thing, it could be anywhere, so we have to do it in general, we have to think of it in general. What if we're in California, where the roads are probably dry most of the time?
There could be hydrogliding.
Okay, there could be rain. So here's what happens with scatter plots and talking about relationships. We do a lot of what ifs. What if
Yeah.
it's cold and the roads are icy? What if there's rain on the road and you're worried about hydroplaning?
Oh, that's what it's called.
That's what it's called, hydroplaning. So we don't what if, here's what we say. In reality, should the temperature outside, no matter what it is outside the temperature, should that affect speeding tickets? Does it really have anything to do with speeding tickets?
No.
No. So we're gonna say no correlation here. And we're not gonna do what ifs, okay? That's what we wanna do with these, but we're not gonna do what ifs. So no correlation. And we're gonna write a sentence answer explanation. The temperature outside should not affect the number of speeding tickets. One really doesn't affect the other. Yes, Carl.
Can I ask a question about the notes?
Mm-hmm.
It's number 4, and it says, choose the scatter plot that best represents the relationship between the number of minutes the pie has been taken out of the oven and the temperature of the oven. And none of them go, like, straight, because, I mean, the temperature of the oven is still the same.
Okay, but what should happen typically when you take something out of the oven? What do?
Shut the oven off.
Shut the oven off. So they didn't tell you that part. But so again, we have to say, well,
Duh.
typically what would happen? Yeah, you're like, duh, that's right. So typically what would happen? The oven would get shut off, and so then what would happen? The temperature would go down.
And then,
So the longer the pie is out of the oven, was it something about how long the pie's been out?
how many minutes?
So the longer the pie's been out of the oven, thus the oven's been turned off. So as the time increases for the pie out of the oven, what happens to the temperature? It
Drops.
decreases, so it would be, what kind of correlation? Negative correlation.
But none of them go down, like, steady.
Do they have to go down steady? And would it necessarily go down
But
steadily?
there's 2 of them that go down, so
Okay.
one's
I
negative.
I think when we practice on one on the back side of the notes, I think you'll see why that one is not gonna count, okay? Ricky,
Seems pretty positive to me because you're gonna get to eat pie.
Ricky, come on, stop. I'm recording these, people are gonna hear your wonderful remarks.
Okay.
That's amazing.
A runner's time, go to the back side. A runner's time and the distance to the finish line. Make sure you always read these carefully. A runner's time. A runner's time and the distance to the finish line. Sit up. That's what I'm asking you to do. Thank you. A runner's time and distance to the finish line. What do you think, Christian?
A negative correlation,
You think there's a negative correlation? Why?
because the distance is dropping from the finish line. That's time is
So the time, a runner's time, so as the runner's running along and the time increases, what happens with the distance?
it drops.
It decreases because it's distance to the finish line, not distance run, but distance to the finish line. So Christian is right, it is negative correlation. And our describing or our explaining, whichever you want to call it, to support it, we're going to say the longer the time run, the longer the time running, we'll say, comma, the shorter the distance left to run. Okay, I'm trying to make sense with our sentence here. So, negative correlation, sentence form, the longer the time running, the shorter the distance that should be left to run for that race. Here's what we tend not to do. don't pay close enough attention to what are the two things that we're comparing. It would be very easy on this one to say positive correlation because the more time you spend running, the more distance there should be, right? But we have to make sure we read, oh, this was distance to the finish line. That's how much running, how much distance there is left, okay? Okay, now let's look at one of those like Harley was just talking about. Choose the scatter plot that best represents the relationship between the age of the car and the amount of money spent each year on repairs. So, tell me, what do you think should happen when you talk about the age of a car and how much money you're spending on repairs? Yeah?
The age should go up and the price should go up.
The cost of repairs should go up also, the amount you spend on repairs. So that as the age increases of the car, so should the amount of money you're spending on repairs increase. So that should be what kind of a correlation? A positive, or in other words, the point should be climbing from left to right? Okay.
And it can't be
So,
negative.
so which one can't it be, for sure?
A.
No, which one can't it be for sure based on what we just said? C. The points are going down in graph C. That is showing that as it gets older, the total cost of repairs is going down.
Oh,
That's not typical, okay? And now, some of you might be like, yeah, but what if you're driving a BMW? No, you don't get to say what if, remember? Typically what happens, okay? So, now we talk about graph A and B. Now the points are rising from left to right, so which one do we have to toss out and why? Which one should we toss out and why should we toss that one out, Michaela?
A, because it starts at a negative age.
Okay, it starts at a negative age over here. We can't have negative age for a car. So it's got a point down there that shows negative age, so that one has to be tossed out, so it's going to have to be graph B. So we're going to say graph B. Oopsie, maybe it'd be good if I could spell. Okay, graph B. And our reason is, as the car gets older, the cost of repairs increases. So as one is increasing, so is the other. And that's what that one is showing. As the car gets older, the cost of repairs increases. So we don't just pick one, we give a support for it. We don't just say what kind of correlation, we say why, what's going on here. Okay, same thing in your homework. Okay, and then here's our last vocab word. A line on a scatter plot that helps show the correlation between the data sets more clearly. Brooke? Trend line. That one's a trend line. So when you, I don't know if this lesson did it, but there are some math books, or maybe there is another time later on in the book, that there's also another thing they call a trend line, or a line of best fit. I want you to start right now getting those two phrases kind of put together. Trend line means the same thing as line of best fit. So if I say to you, draw a line of best fit, I'm saying the same thing as draw a trend line, okay? Because I tend to call it a line of best fit more than I do a trend line. So I want you to know what I'm talking about. Okay, so we have a graph here where there has been a trend line drawn on it, okay? We can tell that this is on concession stand sales. I don't even right now really even need to read anything about it. I can see that it's about concession sales, and on the x-axis it says how many tickets were sold, and then how many dollars were sold in concessions. But now where's this at? Up in my reading it says it's at a what? What's this at? What's it say in this little paragraph up here above? Where's it at? A movie theater, yeah. So the more tickets that are sold in a movie theater, it appears the more they sell in concessions. Does that make sense?
Yes.
Yeah, we all smell the popcorn when we come in, and even though we're not hungry, we decide we want popcorn, right? Okay, so they have drawn a trend line through it, and when you draw a trend line, here's what you need to keep in mind. A trend line does not have to touch every point in the graph. It has to be straight, though. And it has to go through what would be about the middle of the points. Like, I don't mean right through the points, I mean you have this conglomeration of points, you have this scatter plot of points, you want about as many points above the line as you want below the line. So it's kind of like trying to go through the middle of them, showing the pattern of it. So that's what this says right here, how to draw a trend line. Then they wanted, it says, predict how much money will be collected when 150 tickets have been sold. What did they do to come up with $750? What did they actually do? Isaiah?
They would have went to 150 on the x-axis,
Okay.
and they would have, gone up to the trend line.
Okay. Now, what is every grid line on the x-axis here? How much does it represent? How many tickets sold?
100.
Every grid line, 100?
Yeah.
20.
Oh, whoops. Wrong.
20, 40, 60, 80, 100, 20, 40. The next one would be 160. So 150 is going to be halfway. So I'm going to draw, I'm going to follow up there. Oops, I didn't do very good. I didn't do very well. Okay. Let's try this again. Okay. So I'm going to go up to the line. I'm going to start at 150. I want to be over a little bit more, but and then I'm going to follow that across over to here to the y-axis, and I'm going to make my prediction from that. Now I'm not very close because I got off a little bit. But if I go over here, this is a 700. That's 800. It should fall about halfway between. Hey, you do a prediction for what if they sell 90 tickets? You do that on your paper now for 90 tickets. They sell 90 tickets. What do you predict according to that trend line the concession sales would be? Okay, Hunter, what's your prediction?
600.
600. Okay. What do you think? Ricky, what's yours?
Let's see.
Well, you gotta have it. Isaiah, what's yours? Your hands up, you should have it already.
I'm thinking about 490.
490, okay. Ian, what's yours?
At the 490.
Okay, 490. Christian?
300.
300. Ooh, we got lots of choices here. Christina?
450.
450. Kaylee, that's what you want too? Yeah. Now, again, had I gotten mine halfway between, because it's going to be halfway between this one, which is 80, and that one's 100, follow it up and go over, it should be closer to 450.
Yes.
Now, your trend line has to support your answer. So in other words, when you follow up, you should do just like I'm doing here, with a dashed line, follow up, then follow over to the y-axis, and it should support it, just like when I told you to estimate from your graphs back when we were doing that earlier in the chapter, okay? So we would say, for this one, kind of where mine is at right now, I would probably estimate more like, just the way mine looks, I would probably estimate more like $420, according to what I have drawn there, okay? But I would say this is probably closer to about $450, okay, is where it should come out to. So we use trend lines to make predictions. Doesn't mean it's exactly what it would be, it just means according to the data that has been compared already, this is what we could predict would happen, okay? Any questions? Further questions, yeah?